All right, so remember that we use implicit differentiation to differentiate um, functions, equations, right, where y can't be written explicitly in terms of x, right? The top page one, right, y is written explicitly in terms of the variable x. And so using the rules of differentiation is pretty straightforward, differentiating that equation, okay? But down here, we cannot write y explicitly in terms of x. And so we can still find the derivative of y with respect to x, but we have to use implicit differentiation. And before we did an example, right, we had to clarify what the derivative of y to the nth power is with respect to x. And remember, y is the same as f of x, right? Y is equal to f of x. And we learned from the chain rule that the derivative of f of x to the nth power with respect to x is equal to n times f of x to the n minus 1 power times the derivative of f of x. So using the general power rule, right, we can show that the derivative of y to the nth power with respect to x is equal to n times y to the n minus 1 power times the derivative of y with respect to x. Okay, so that's very important. And just to clarify, right, we know the derivative of x to the n with respect to x by the power rule is n times x to the n minus 1. And if instead of x we have y, the derivative of y to the nth power with respect to y by the power rule is n times y to the n minus 1. What's different about this up here and this down here is we're differentiating with respect to x up here. Down here we're differentiating with respect to y. Okay? So that's the big difference. Okay? What's inside parentheses here is this expression involving the variable y, and we're differentiating with respect to y. So we just use the power rule. Up here inside parentheses, we have an expression in the variable y, but we're differentiating with respect to x. So we have to use the general power rule, then the chain rule. All right. So on page 2, right, we did our first example in finding the derivative of y with respect to x using implicit differentiation. Okay. So you can see this first example we did is kind of quadratic in form in the variables x and y. And now down here, let's take a look at this problem down here where we have the trig function involved. So we have y is equal to, or excuse me, y times cosine, right? So that's y times cosine of x is equal to x squared plus y squared. Okay. So the derivative of the left-hand side with respect to x is equal to the derivative of the right-hand side with respect to x, right? So we have the derivative with respect to x of y times cosine x is equal to, okay, now is equal to the derivative of the right-hand side with respect to x. But by the sum rule, this derivative of the right-hand side is equal to the derivative of x squared with respect to x plus the derivative of y squared with respect to x. Okay. Now, on the left-hand side, we're taking the derivative of product of two functions, right? So we got to use the product rule. And so y is my first function, and cosine of x is my second function. Okay. And so employing the product rule on the left-hand side, I use the form derivative of the first times the second plus the derivative of the second times the first. Okay. Remember, there are 8 different expressions for the product rule. Okay. So the derivative of y with respect to x is just dy over dx. Then we multiply that by the cosine of x. Then we add to that the derivative of the second function. Well, the derivative of cosine x is minus sine x. I gotta change that plus to a minus. And then times the first function, y. So the derivative of the left-hand side of our original equation, okay, is the derivative of y with respect to x times cosine x minus sine x times y. Okay. Now on the right-hand side, derivative of x squared with respect to x, we just use the power rule, right? Derivative of x squared with respect to x is 2x. And the derivative of y squared with respect to x, now we got to do the general power rule, right? Bring the 2 down in front of the y, and then multiply that by the derivative of y with respect to x. So you can see these can get kind of messy, right? So when you're doing the homework, be very careful, right? Because if this is a plus instead of minus, you know, web assign's going to tell you you're wrong. Okay? So you just slow down, take your time, right? It's not a gazillion problems. And I think it's like 12, something like that. You know, slow down, take your time, and focus on getting the math correct. Okay. Better to spend 20 minutes getting the math correct than try to solve it in 5 minutes. Okay. All right, now to find the derivative of y with respect to x, we need all the terms, right? We got 1 term, 2 terms, 3 terms, 4 terms. Get all the terms with dy over dx on one side, and all the terms without dy over dx on the other side. Okay? And then we factor out the dy over dx like we did yesterday, and then divide. So keep this guy right here where it is. And so I got to move minus sine x times y to the right-hand side by addition. Okay? And I got to move this 2y times derivative of y with respect to x to the left-hand side by a subtraction. Okay? So maybe we'll do it in 2 steps. We have the derivative of y with respect to x times the cosine of x is equal to 2x plus 2 times the derivative of y, or 2, said that wrong, equal to 2x plus 2y times the derivative of y with respect to x, right? Plus the sine of x times y. Okay? Now, when you're doing this problem in WebAssign, right, you can do 2, 3 steps at a time, right? You don't have to do one at a time like I'm doing now, right? Just be very careful with the addition and subtraction. Okay. All right. So now I can move this 2y times the derivative of y with respect to x to the left-hand side by subtraction, right? That term. So I have the derivative of y with respect to x times the cosine of x minus 2y times the derivative of y with respect to x is equal to 2x plus, now maybe so I don't remember the x going to sign function is called the argument. So maybe we don't get y and x, think that the argument is xy going into sign. let's put the y in front of the sign just to clarify things. So we have y times the sine of x. So now we know the argument going sine function is just the variable x, okay, not xy. All right. Now you can see on the left-hand side, right? We got derivative with respect to x, dy over dx, right? All the terms of dy over dx on the left-hand side, and all the terms without it on the right-hand side. And so now I got two terms on the left with dy over dx in each term. So now I can factor out the dy over dx. And so when we do that, we have the derivative of y with respect to x times, right, when we factor out the dy over dx, we're left with cosine of x minus 2y after we factor out the dy over dx, right? And then on the right-hand side, we have the 2x plus y times the sine of x. Well, this is a product on the left-hand side, right? So I can divide, right? This is product of two factors. Dy over dx is the first factor. What's in parentheses is the second factor. So I can divide both sides by what's in parentheses and isolate the dy over dx on the left-hand side. So the derivative of y with respect to x is equal to 2x plus y times the sine of x over what's in parentheses here. Cosine x minus 2y. Okay. And so remember what I said yesterday, right? Typically your derivative, right, derivative of y with respect to x will contain both the variables x and y. Any questions on that, ladies and gentlemen? Okay. Calculus is cool stuff. Okay. I mean, when I was your age and professor was up here doing this, I just thought I died and went to heaven. Okay. I really did. Couldn't believe how cool this stuff was. All right. No questions? Okay. So I flip over to page 3. Right? We're going to do another one. And then on page 4, right, we're going to find the equation of tangent line. And then we'll be done with this section. Yeah. So we'll be done and then we'll start on the next part. All right. So we have the equation x times e to the y is equal to x minus y. All right, so this case, right, so the first one we did yesterday, right, was sort of quadratic in form, right, involving x squared and y squared. And then the last one we did involved a trig function, and now we got one involving the natural exponential function, okay? So to find the derivative of y with respect to x, right, we differentiate both sides with respect to x. And so on the left-hand side, we have the derivative of x times e to the y. Derivative of x times e to the y with respect to x. And then on the right-hand side, we have the derivative of x minus y with respect to x. And using the difference rule of differentiation, this is equal to the derivative of the first term, x, minus the derivative of the second term, y. by the difference rule. All right, so again, right, we're taking a derivative of a product. So we got to use the product rule, right? X is the first function, e to the y is the second function. And so again, the form of the product rule that I used is derivative of the first times the second plus the first time, so the derivative of the first times the second plus the first times the derivative of the second. Again, right, there are 8 different expressions for the product rule. Okay, you get to pick the expression you want to work with. All right, so the derivative of x with respect to x is 1. And so then we had 1 times the second function, e to the y. And then plus the first function, x, times the derivative of the second function. Okay? So we're taking the derivative of e to the y with respect to x, right? Y is a function of x. So we got to use the chain rule. And the chain rule says the derivative of e to a function of x is itself times the derivative of the exponent with respect to x. So derivative of e to the y with respect to x is e to the y. And then we got to multiply that by the derivative of the exponent with respect to x. Okay? So finding this derivative, right, we had to use the chain rule for the natural exponential function. Okay? This is like e raised to the g of x, right? E raised to a function of x. And so by the chain rule, that's equal to itself times the derivative of the exponent. The derivative of the exponent is the derivative of y with respect to x. On the right-hand side, derivative of x with respect to x is 1. And then we subtract from that the derivative of y with respect to x, which we just write as dy over dx. Right? That's how we write the derivative of y with respect to x. All right. And so the strategy is the same as before, right? We got 1, 2, 3, 4 terms in this equation. And so we want all the terms involving the derivative of y with respect to x on one side, and all the terms without the derivative of y with respect to x on the other side. So we can move this, right, we'll do it in 2 steps again. Okay, but again, if you were doing this at home, right, doing your homework tonight, you could do 2 steps at a time, 3 steps. So we're going to move this dy minus dy over dx to the left-hand side by addition. And so we have 1 times e to the y is e to the y. Then we have x times e to the y times the derivative of y with respect to x. And then when we add dy over dx to both sides, we have dy plus dy over dx on the left-hand side, and that's equal to 1 on the right-hand side. And now I can move this e to the y to the right-hand side by subtraction. Right? Subtract e to the y from both sides. And so when I do that, I have x times e to the y times the derivative of y with respect to x plus dy over dx is equal to 1 minus e to the y. And now you can see on the left-hand side, you got two terms. They each contain dy over dx, so I can factor out the dy over dx. And so I'll factor it out to the right. And so I have x times e to the y plus 1 times the derivative of y with respect to x, right? If I distribute the dy over dx back inside the parentheses, I end up with this expression on the left-hand side up here. And that's equal to 1 minus e to the y. And now you can see, right, I have a product of two factors. And so I can divide both sides by the first factor and isolate the dy over dx. So we have the derivative of y with respect to x is equal to 1 minus e to the y power over x times e to the y plus 1. And so that's the derivative of y with respect to x for this equation that we started with. Okay? And again, it's in terms of x and y. Okay. Cool beans? So flip over to the next page, and we'll use implicit differentiation, okay, to find the equation of the tangent line to the curve at the point 5 pi. So here we have, right, an equation in x and y. Remember, y is a function of x. Okay. And we want to find the equation of the tangent line in the graph of this function, graph of this equation, at the point pi pi. Okay. So the x coordinate is pi, the y coordinate is pi. Okay. So maybe what we ought to do first is see if the point pi pi is actually, oh, that reminds me, happy Pi Day. It's March 14th. Okay. So everybody's at the supermarkets buying apple pie with the Greek letter pi cut into it. Okay. All right. So let's see if this point pi pi is actually on the graph of this equation. So we have the sine, right? So remember, pi is the x coordinate is equal to pi, y coordinate is equal to pi. So we put pi in for both x and y, and we have the sine of pi plus pi is equal to 2 times pi minus 2 times pi. We have 2 pi minus 2 pi. Well, right, the argument going into the sine function is pi plus pi, which is equal to 2 pi. So we have the sine of 2 pi, and on the right hand side we have 2 pi minus 2 pi, which is 0. Is this a true statement? Is the sine of 2 pi equal to 0 from the unit circle? Well, you know the sine of 0 is equal to 0, right? And 2 pi radians, right? So here is on the unit circle. Here's it, all right? Here's the angle 0 radians, and 2 pi just makes a circle, right? 2 pi radians just makes a circle. So the sine of 0 is equal to 2 pi, and the sine of 2 pi. Sine of 0 is equal to 0, and sine of 2 pi is equal to 0. Right? Because 2 pi radians just makes a circle. So this is a true statement. So the point pi pi is indeed on the graph of that equation. Okay. We don't know what the graph looks like, but we know the point is on there. So now we can calculate the slope of the curve at pi pi and get the equation of the tangent line at the point pi pi. Okay. So we have the sine of x plus pi is equal to 2x minus 2 pi, and we're going to get the equation of the tangent line at the point pi pi, right? So both the x coordinate and the y coordinate are equal to pi. So to get the slope of the curve at that point of tangency, we got to differentiate this equation with respect to x. So we differentiate the left-hand side with respect to x, and we differentiate the right-hand side with respect to x. So this is going to be kind of difficult to write, but we're differentiating the sine of x plus y with respect to x, and then we're differentiating the right-hand side with respect to x. So by the difference rule, the derivative of the right-hand side with respect to x is the derivative of 2x with respect to x minus the derivative of 2y with respect to x. Okay. So we got to use the chain rule on the left-hand side in finding that derivative, because the argument going into the sine function is a function of x. Y is a function of x, and so x plus a function of x is a function of x. Okay. So we got to use the chain rule. And you start from the outside and work in. So what's the derivative of the sine function? Cosine. So we have cosine of x plus y, and then we got to multiply that by the derivative with respect to x of x plus y, right? That's the chain rule. Derivative of the sine function evaluated at x plus y is cosine x plus y, and then we multiply that by the derivative of the inner function with respect to x, and the inner function is x plus y. Okay. On the right hand side, the derivative of 2x with respect to x is 2, and the derivative of 2y with respect to x, well, the 2 is a multiplicative constant, we just carry it along, and we multiply that by the derivative of y with respect to x, which we denote with dy over dx, right? The derivative of y with respect to x is dy over dx. So far, so good. So now, let's clean this up. Derivative of x plus y with respect to x. So we have the cosine of x plus y. And so the derivative of x was, right, so we're using the sum rule. Derivative of x with respect to x is 1. And this has got to go in parentheses now. Okay. And the derivative of y with respect to x is dy over dx. And that is equal to 2 minus 2 times the derivative of y with respect to x. So this guy's a little messy, okay? And so you gotta be really careful. Well, we gotta get to dy over dx all on one side, right? And so to do that, we have to distribute the cosine of x plus y inside the parentheses here, okay? And then we'll be able to get the dy, the terms with dy over dx on one side and the terms without it on the other side. Okay. So this entire guy, okay? So remember, x plus y is called the argument going into the cosine function. And so this entire guy, the cosine of x plus y, gets distributed inside the parentheses. Okay. Now you guys know the distributive property, right? A times b plus c is equal to ab plus ac, right? That's all we're doing. But our a in this case is cosine of x plus y, our b is 1, and our c is the derivative of y with respect to x. Okay? So we're doing basic distributive property, but with more complicated expressions. Okay? So cosine of x plus y times 1 is just the cosine of x plus y. And then we have the cosine of x plus y times the derivative of y with respect to x. So we're not doing anything new with the distributive property. We're just doing it with more complicated expressions. Okay. Then on the right-hand side, we have 2 minus 2 times the derivative of y with respect to x. And now you can see this equation has 1, 2, 3, 4 terms. 2 of the terms have dy over dx in them, 2 do not. Okay. So we got to move this cosine of x plus y to the right-hand side, and we got to move this minus 2 times the derivative of y with respect to x to the left-hand side. So let's kill 2 birds with 1 stone in this problem. So we're going to move the minus 2 times the derivative of y with respect to x to the left-hand side by addition. Okay? And we're going to move this cosine of x plus y to the right-hand side by subtraction. We're going to do 2 steps at once, right? We can do that. So when I add 2 times the derivative of y with respect to x to the left-hand side, I have 2 times the derivative of y with respect to x plus the cosine of x plus y times the derivative of y with respect to x. Okay. Remember, right? So I actually moved it, not there, but here. Okay. And now I'm subtracting cosine of x plus y to both sides to move it to the right-hand side. And I have 2 minus the cosine of x plus y. We're almost there, ladies and gentlemen. Okay? We're almost there. Are you able to follow me? Or have I lost you? If I lost you, say something. Okay? We can go back up. All right, so on the left-hand side, we got 2 terms with dy over dx. So we can now finally factor out the dy over dx. And Then when we factor out the dy over dx, what we have left in parentheses is 2 plus the cosine of x plus y times the derivative of y with respect to x is equal to 2 minus, on the right hand side, 2 minus the cosine of x plus y. So again, we have a product of two factors on the left hand side. Second factor is dy over dx, so we can divide both sides by what's inside parentheses and isolate the derivative of y with respect to x on the left hand side. So we have 2 minus the cosine of x plus y over 2 plus the cosine of x plus y. Now we're not done. I'm just boxing what we finally know to be the derivative of y with respect to x for our original equation. So to get the equation of the tangent line, we need two things, right? The point of tangency and the slope of the curve at the point of tangency, right? Because the tangent line and the curve have the same slope at the point of tangency. So we know where the point of tangency is. It's at point pi pi. What we need now is the slope. So to get the slope of the curve and the tangent line at the point of tangency, we put in pi in for x and y. Okay. So we have the derivative of y with respect to x, and now we're going to evaluate the derivative of y with respect to x at x equals pi and y equals pi. So remember Leibniz notation, we got to use a bar or something when we're evaluating the derivative. And so now we put in pi in for x and y. In the derivative, we have 2 minus the cosine of pi plus pi over 2 plus the cosine of pi plus pi. Well, pi plus pi is 2 pi, right? So actually, I'm going to keep going to the right. Remember what the cosine of 2 pi radians is? So remember, 2 pi makes a circle, right? So cosine is 0, and the cosine of 2 pi have the same value, right? Cosine function has a periodicity of 2 pi radians, okay? So here's the unit circle. Here's 0 radians on the unit circle. So cosine is 0 radians, and then 2 pi is just a circle, right? So it brings you right back to where we started here at 0 radians. So cosine of 0 and cosine of 2 pi have the same value. You guys remember what cosine of 0 is? 1. So this so cosine of 0 is equal to 1. Cosine of 2 pi is equal to 1. So this is equal to 2 minus 1 over 2 plus 1, which simplifies to 1/3. So the slope of the curve for this equation at the point pi pi is equal to 1/3. Okay. So m is equal to 1/3. The slope of the tangent line, right, is equal to 1/3. So, slope-intercept form, y equal mx plus b. So we got to solve for b. So we plug in for y, which is equal to pi. M is equal to 1/3. X is equal to pi. And now we solve for b to get the y-intercept. Well, pi minus 1/3 pi is 2/3 pi. So b is equal to 2/3 pi, or 2 pi over 3. Let me write it out this way. 2/3 pi, which is equal to 2 pi over 3. And so the equation of the tangent line at that point of tangency is y equals 1/3 x plus 2 pi over 3. How long did it take us to do that problem? Anybody notice? Did it? But you do it in 5 on the exam. I wouldn't do this to you. Okay. So this is the equation of the tangent line that we've been seeking. Okay. Any questions, ladies and gentlemen? Okay. So you have everything you need to successfully complete the WebAssign homework that is due tomorrow night.